Hey guys, welcome to a brand new physics tutorial video. Did you miss me? I hope you not. In today's video we'll check and analyze a program about net force, motion, friction and acceleration. The first simulator we got is a very interesting one. We can see a group of different sized blue people and a group of different sized red people. Each one of these little men can pull a rope in order to bring this cord to one of the edges of the screen in this way. We can notice that if we put two same-sized men pulling from every side, the cord doesn't move at all. That's because the force that the little blue man applies to the object has the exact same magnitude than the little red man force, but one of them is positive and the other negative, cancelling each other and creating an equilibrium in the horizontal sum of forces. A fun fact is that if you let all one group pull to one side, there will be a point where a single little blue man won't be enough to stop the card in time. That's because the card already had an acceleration when the blue man moved into the equation. That is described in Newton's first law of motion, which is inertia. The second exercise shows another of these little robots, now orange, who applies a force on a box on a skateboard. But this time there is no horizontal displacement limits, so you can push until the man falls. We can notice that there is no such thing in this world as air resistance, what exists in our real world. The object keeps sliding infinitely, what doesn't happen in real life. Also, we say that the more mass you put on the skateboard and try to move, the more difficult it'll be, even though there is no friction as the object is moving on wheels. This is described in Newton's second law of motion that states that the mass of an object will always be proportionally inverse to its acceleration. The third model is about friction. There is no longer a skateboard, so the mass of the object will be multiplied by the gravity in order to get the weight, and that will be multiplied by the friction coefficient. In this case, we can see Newton's third law of motion as the box applies a force on the man when the man applies a force on the box. And also the man is able to move by applying an horizontal force on the floor. That's why we can walk and do a lot of things we couldn't without friction. We can notice that the box struggles to move when it just starts to do it. That's because when the box starts moving, it has a static friction coefficient, which is greater than the kinetic one, which applies when the box is already moving. The last one. This simulator represents almost the exact same as the other simulators. What changes in this case is that we finally get air resistance and acceleration gets lower as we stop applying an external force on the object. And that will be all for today. Don't forget to hit that subscribe button and hit that like button down below, especially Bombo, who I think is the only person that will ever listen to this. See you in the next physics video tutorial.